Welcome to this video going over the practice problems involving aldol reactions and aldol condensations. So the question is, how would you make these aldol products, potential aldol products? One of the ways we know that they're going to be aldol products is they have functionalization at the beta position. Like this is a beta alcohol, beta hydroxy ketone, or this is alpha beta unsaturated ketone. This would be a beta hydroxy aldehyde. It's beta because this is alpha, that's beta carbon, right? And so how do we make these? Some of these we could do it through regular mixed aldol method. Some of these we can't because of the reasons we discussed in class. So the first thing is we need to be able to see the aldol bond, and hopefully it makes sense that this would be the aldol bond. So if you can picture this carbon being enolate and adding to that carbonyl carbon as a nucleophile, that's how this would happen. Okay, so the first problem here, we should be able to make this rather simply from a self aldol addition reaction. So it would be just this ketone, and that would do that. Okay, the second one, maybe just to, because that's the first one, we'll maybe quickly go over the abbreviated mechanism. So this would be the enolate we're expecting. Maybe let's say we'll just use sodium hydroxide or something, and that enolate would then attack the ketone of yet another molecule. So, and after the oxygen here would pick up a proton from the solvent, that would be the product there. Okay, so that's the first one. Second one, this would be an aldol condensation reaction. This is the new bond formed. So the dissection here, retrosynthetically speaking, would be right there. Okay, so this we should be able to make because this piece, which is going to have to be an aldehyde. I know that because the would-be carbonyl carbon right here has a hydrogen, so that has to be an aldehyde. That doesn't have an enolizable alpha proton, right? So like we should be able to do this with benzaldehyde and acetone. And this combination works because the acetone can become an enolate, but the aldehydes can't. So this is a mixed aldol, or cross aldol, we might have called it in class, that works. Okay. This next one is actually a bit more tricky because you might notice that the aldol addition bond is right there, but the two pieces have different number of carbons. So this piece has 1, 2, 3, 4, 5 carbons. This piece has 4. So it is a mixed aldol or cross aldol. And both of these aldehydes could become an enolate, right? Both of those aldehydes would have enolizable proton here and there, so that would present an issue, right? Like as we talked about in class, you could get a mixture, which is not a good thing. So what we don't want to show, this is the wrong answer, is we're gonna just mix these aldehydes and hope that it would work. That is not the right way to do this. Okay. So what can we do? One of the ways we could do this would be to try to specify which aldehyde is going to have to be the enolate. So one of the ways we could do that is this pentanal. We treat that with LDA at cold temperature to form the enolate. Specifically, and then treat that and then add the butanol, and then do some sort of acidic aqueous workup. So that would afford this aldol addition product, okay? Because LDA, that's an irreversible step, okay? The next one, this is the alpha carbon, that's the beta carbon. So the dissection would be right there, and so this should be able synthesizable from molecule that would have 1, 2, 3, 4, 5, 6, 7 carbons. 6, 7 carbons, and that, and we just need some strong base. This would be regioselective, because if the enolate forms at this carbon instead, it would form a 7-membered ring that would be too big for cyclization normally, so it would be specific for this 5-membered ring product. Now for this last one, again, the dissection would be right there after dehydration. So the product is going to have, the starting material should have 1, 2, 3, 4, 5, 6, 7, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8 carbons. There's a ketone on carbon number 2, and there's another ketone on carbon number 7. So this would do it. Since we're encouraging dehydration, we would have to heat that. So hopefully that makes sense to you. And again, it would be a good exercise and practice for you to go through the mechanism for each